Okay, let's now look at the backpropagation in detail. So the first step is the forward propagation. That's the most easy one. Okay, so let's select this example 5 here and refresh. Let's use this one. Okay, so what is happening in the forward propagation? Well, from the output here, it is sent through to this node here, using the weight here. And this is the sum of all inputs to this neuron here. And this one is the output. So this is the input and this is the output. Input, output. Okay. Let's see what's happening. So to use this, we need to see the function here. This one. Okay. Okay, so if I push forward propagation, the value as the output of this one is oh yeah, sorry, we have to show the calculation also. Here. Let's see what's happening. I push the button, I show the calculation, and you can see that here from neuron 0, which is this one, this is 1, 2, 3, 4, 5, 6, 7. Okay? So from the first layer, neuron 1, 2, 3. This is 1, 3. It is 0.05. Okay. This is 0.05. So the output of the first neuron times the weight of this here is 0.15. Here is the same as 0.075. Okay. So the sum at this point is 0.07, but we are not finished. We need this and this. So from the neuron 1 to 3 is the same. 0.1 times 0.25, which gives us the sum of 0.03. Also the sum at this point after these two. And then we need this one. Is the number 2 is 1 times 0.35. 0.35 here, okay? Which gives us 0.35, which the sum is 0.3825. And you can see the sum here from these three gives us 0.385. Now the strange point here is that the output of this neuron is more than the input. So the input is 0.38 and the output is 0.59. How can that be? That doesn't make sense. Well, that's why we use a function. In this case, we use the sigmoid function. You can see it like the output is getting normalized. So if you look at the sigmoid function, you can see that if the value, the input value is the x-axis here, if it's less than 5, let's say 5, it still is bigger than 0. So the sigmoid function, it doesn't matter how small the number is, it will always be a little bit more than 0. And the same with how big it is, it will always be almost 1. It will never be 1. So the output will be somewhere between 0 and 1, no matter what you put into it. And now you can see why the output is bigger than the input. Because we are setting 0.38 in, which is somewhere here. If you can see, let's say this is 1, 2, 3, 4, and 5. Okay? So if this is 0.38, you go up here, and you see the y-axis, which is the output, is going to be a little bit bigger than 0.5. We're somewhere around 0.6. This explains why a smaller input gives a larger output. Okay. So this is the forward. Now this output is sent through this wait and into this one, and the same for everything. So this is the basic idea.